Hello, I am Spandana. I am a research fellow in the School of Cultural Texts and Records. For the last 10 years, I have been working on textual computing, that is, preparation of computational tools to work with texts. I am here to talk about basic computational tools. So, what could be a basic computational tool? Well, of course, the most basic of them is a search tool. I call search a basic tool because not that it's very easy to create one. In fact, it's not really easy to create a good search engine. But in a way, what it does at the ground level is simple enough, and the inherent logic of a search tool is used as a stepping stone for many advanced tools. So that makes it quite the basis of many computational applications that work especially on texts. Just to be clear, when I say search, I do not mean a search engine. What are search engines? Well, we know a few of them. Google, of course, is one, probably the most popular web search engine. A search engine is something that initiates a program that uses a basic search tool along with 2 or 3 other things, such as a crawler software that crawls through your file system, file directory, and finds out files that contain the match, the word match, the search term that I have given to the search tool. So, the crawler creates a sort of database that contains the contents of the files, and the search tool basically works within that index or database. So it's a far more complicated thing than a basic search tool. We are talking about the basic search. So what is a basic search and how does it work? To put it in an easy to understand way, let's start at the beginning. When you write some words in a file, the type text, which is not some commands written in some programming language, the computer recognizes your input as a stream of characters. Now, when you want to search a particular word within that file, that string of characters, it simply checks your input, the search input, a new stream within that previous stream, and tries to find character matches. Not only character matches, but also match in the respective positions of the characters. That is, let's say you're searching dog within, gone are those days when I could spend the whole afternoon at the porch reading a book with Pablo, my dog, peacefully sleeping beside me. Notice that this sentence has D, O and G at more than one places. But there is only one occurrence of D, O, G in that order, that is, the respective positions matching with those in the search term. So, not only characters but also their respective positions. Now, what if we want to complicate this a bit more? What if what I said earlier is a stiff and strict kind of search? What if we insert the term regenerate and the search tool returns not only instances of regenerate but also regenerating and regeneration? There could be 2 ways. The short way, the search tool leaves the last E of regenerate and searches by the regenerate without the last E. The search tool should have a standing instruction about leaving the last E, or in a more programming friendly way, it should learn to ignore the mismatch of the last character if all other characters and their respective positions match. Now, there could be more such rules of exception as we keep on thinking about words that change more than the last character when they change from, say, present tense to past tense, like sing and sang. You cannot fit it within the previous rule. You cannot say just don't bother about one character mismatch at any position while the other three match. Just show the results. Then it would bring not only sang but ring too. In cases like these, people have thought about creating a supplementary list of words related to the word that has been submitted for search. For example, if the search tool has a complete list of words and their transformation when used as a different parts of speech, or a table of words in different tenses, the tool should first try to match the search term within that list. When it finds a match there, it gets a set of supplementary words to search to, which could increase the number of relevant matches. This could be one way to have a semantic search tool too, which is a more advanced state, where I, the user, desire the computer to understand what I am talking about. The computer should bring back results not only matching the specific word and its forms, but also words similar in meaning, that is, the word that I have given. The machine should understand in a way the meaning of the word, of that word. In this case, we need a thesaurus up and running hand in hand with the search tool. I insert a word in the search field, it gets searched into the thesaurus first. It finds a match, checks what are the alternatives, searches for all of them within the text file. There could be other kinds of specialized searches. Let's say I have a repository of travelogues at my disposal. I want to know how many places have been mentioned in 1, 10, or maybe in all of them together. I do not know what could be the places that have been mentioned, so I cannot give a specific term to start searching with. One way of searching could be proximity search. In proximity search, I can give more than one such term and give instructions such as, say, if these 2 or 3 words occur within 5 or 10 words distance or proximity between them, bring up those occurrences. How would a computer understand the number of words that are between? It simply counts the spaces in between. Anyway, I may think of place and name and set off such a search. But these are more useful if I know what I want. For example, I want to check whether in a set of documents the word nation has been used in proximity with revolution. There, a proximity search might be more useful. But in our case, with the travelogues, we need something else, a more elaborate tool. What could that be? First, while creating the digital text, I can keep a list of names of places mentioned in it. This way, when all the texts are transcribed, I will have a full list of all the places. I can then provide the search tool user a list of options to choose from when he or she wants to search places. Similarly, I may list dates mentioned. The metadata regarding the travelogue, that is, who wrote it, when it was written, which country that person traveled, could also supply filters for the search. The user is given an option to choose particular years, or he can submit a query using a place name, which can bring up books that are about travels to that place. We can supply him more options to define his or her search more. We can use what programmers call the logical operators. One can limit one's search by using and, or not. Say, I want to see results related to Kolkata or Calcutta, but not Bangladesh. This will bring up results that have either Kolkata or Calcutta mentioned within them, but not Bangladesh. One can use these operators in any combination, depending upon the flexibility of the search tool. One other way to define places, years, and persons mentioned within the text is to mark these words with some some tags so that when I run a search tool, the tool should recognize the tags and understand the words in between are special in some way. There are many standardized conventions of doing that. You can mark all the place names in the text. So now if someone gives a vague search about places mentioned in so-and-so texts, you can return relevant results to that query. There could be spelling variants of a place name. We need to keep that in mind too. That will need another list of alternate names like Mumbai, Bombay to start with, just like a tense table or thesaurus. Sometimes to make a repository more useful and informative, keywords listing like places, persons, events mentioned in the book, and marking those words within the text are both employed. But as we can understand, it's a time-taking process. Now let's go to a completely, at least seemingly different tool, a collation tool. It is specifically used for finding out relationships between versions of a text, to find out changes that a text has undergone from its initiation to its end. A collation tool compares different versions of same text and points out differences, marking the places where they occurred. How does it do that? Basically, collation 2 is an advanced search. What we learned about the basic search function, matching two strings of characters, is the basis of collation 2. But it uses that in a much more complicated way. At the ground level, a collation tool compares two strings character by character. But then, say I have two texts. Other than the portions that match, text A has some chunks missing that are present in text B, while it has some text present in itself that are not in B. Also, some portion of the first paragraph of A has shifted to the third paragraph in B. A good collation tool should identify and show all of this. So, what will it do? It will start matching A with B, character by character, keeping their order and position within the full document in mind, and checking what the other document has in that position, and also whether it can find a match at any other position too. A search function reports only matches, but this tool will report matches, mismatches, and also whatever else is there or whatever else that is missing in there. Characters form words, words form sentences. The programmer decides how to report the results. A single character can find lots of irrelevant matches all over the text, but a word will find less. Also, a string of words will be more definitive. For example, is a very common word, but Meera is always the first to come to the class is a sentence that needs 10 consecutive matches. So how many characters should match to call two words similar or same? And how many words between two sentences should match to call them a match? Similarly, how many sentences within a paragraph and how many paragraphs within a chapter? It depends on the language's intrinsic rules. In English, prepositions have separate identities. However, not in Bengali. Two English sentences thus may find higher matches than two Bengali sentences. On the other hand, it might also be subjective to the user and the texts. Say I am comparing two texts that are widely varying, though they are versions of the same title. I might say a 40% match will be enough for me to declare that these two texts are variations of the same story. So that's how a collation should work. You can check examples of a good collation tool in the Vichitra site, Vichitra Tagore online video site, or you can check Juxta and Collate. These are very renowned collation tools. So these were the few basic tools. I hope we can talk about this and other aspects of computation tools at a later time in more